Okay, so today we're going to be looking at another rotational dynamics problem. So a billiard ball is initially struck such that it slides across a snooker table with a linear velocity v0. The coefficient of friction between the ball and the table is mu. At the instant the ball begins to roll without sliding, calculate its linear velocity, the time elapsed after being struck, and the distance traveled by the ball. So we can first visualize this problem by drawing it. So we have the ground, the snooker table, and billiard ball rolling across it. So we'll go this way with a v0, and there's friction between the ball and the table with mu. So initially, v0 is greater than the omega r, so it will slip. So initially condition is v0 greater than omega r. But then after, since friction will take away some velocity, the final velocity v will equal to omega r. So it won't slip anymore, it will start to roll. So when it's slipping, we know the formula is ma is equal to negative mu gm, which gives you a is equal to negative mu g. Now we can relate back to one of our kinematic equations. V is equal to v0 plus at. So in this case, it will be equal to v0 minus mu gt. Now, after, it will begin to roll with no slip. So after that, the torque will just be equal to I alpha, which will also be equal to Fr. Now we can sub in the values we know. So we know I, the moment of inertia of a sphere, is just going to be equal to 2 over 5 mr squared. I carry alpha down here. And we know force from up here is just going to be equal to mu gm, and we carry r here. Now isolating for alpha, we get alpha is equal to mu gm r over 2 over 5 mr squared. Simplifying this, you'll get 5 mu g over 2r. Since we know acceleration is constant, we can use the equation angular velocity is just equal to angular acceleration times t. So this gives you angular velocity is just equal to 5 mu gt over 2r. Now we can relate it back. If we know this equation, we can solve for ugt in terms of omega. So we get mu gt is just equal to 2r omega over 5. Now we'll plug it back to the initial equation all the way up here, where v equals to v0 minus mu gt. We know this equation, so we can do equal to v0 minus 2r omega over 5. So, and we know r times omega is just equal to velocity. So you get v equal to v0 minus 2 over 5v. Put this on the other side, we will get 7 over 5 v equal to v0. So we know that at v equal to 5 over 7 v0, it will stop sliding and start rolling completely. So for part B and C, we're going to find the time elapsed after being struck and the distance traveled by the ball. But these two parts are mainly trivial because you use the kinematic equations, and we already have the velocity equation. So I suggest you to pause the video here and try out yourself. So for part B, we know v equals to v0 minus mu gt. So we rearrange for t. So we get t is equal to, put mu gt over here, v over there. v0 minus v over mu g, which is just equal to, using this equation, v0 minus 5 v0 over 7 over mu g. which is just equal to 2 over 7 v naught over mu g, or 2 over 7 v naught over mu g. So for part C, you want to find the distance traveled by the ball. So we can use the kinematic equation v squared equals to v naught squared plus 2as. We know acceleration and v, so we can isolate for s. We get s equal to v squared minus v naught squared over 2a. And we know v squared is just equal to 5 squared v naught squared over 7 squared. So we get s is equal to 25 over 49 v naught squared minus v naught squared over 2. You know acceleration is just equal to negative mu g. So you put negative mu g here. Now we evaluate this expression. So we get it's equal to negative 24 over 49 v naught squared over negative 2 mu g. We divide 24 by 2 and cancel out the negatives. We get 12 over 49 and v naught squared over mu g. And that is it for this question.